Hi everyone, welcome to my YouTube channel. Today, I will be talking about control charts, IMR chart. Let's get started. There is another control chart that I would like to talk about today, individual control charts. This chart should be used when there is only one data point to represent the situation at a given time. Okay. There are many situations in which the sample size used for process monitoring is equal to 1. For example, there is a manufacturing line with automated inspection and measurement system. Every unit manufactured is analyzed, so there is no basis for rational subgrouping. The second example is that data comes available relatively slowly, and it's difficult to allow sample sizes to be more than 1. The long interval between observations will cause problems with rational subgrouping. The third example is that measurements on some parameter will differ very little and produce a small standard deviation. In such situations, the control chart for individual units is useful. In many applications of individual control chart, we use the moving range of 2 successive observations as the basis of estimating the process variability. The moving range is defined by this equation. For example, for these data, the sample average of 20 observations is 300.5. The average of the moving ranges of 2 observations is 7.79. To find the moving average for each observation, for example for this one, subtract 288 from 310, and so on. To set up the moving range chart, we need to find the upper and lower control limits. So we need D3 and D4. To find D3 and D4, we need to use this table. In this case, D3 is 0 and D4 is 3.267 for n equal to 2, because we are using the difference of 2 successive observations. The moving range chart has center line of MR equal to 7.79 and lower control limits equal to 0 and upper control limit is 25.45. Notice that no points are out of control. Since we are using the moving range of 2 observations, then D2 is equal to 1.128 from this table. The USL and LSL can be found from these formulas. There are no out-of-control observations on the individual's control chart. The interpretation of individual control charts is very similar to interpretation of other control charts. It's clear one should look for possible assignable causes if there is any point out of the limits. So, IMR charts are used to monitor the mean and variation of your process when you have continuous data that are individual observations, not in the subgroups. We can use these control charts to monitor process stability over time so that you can identify and correct instabilities in process. For example, a quality engineer monitors the manufacture of liquid detergent and wants to assess whether the process is in control. The engineer measures the pH of 25 consecutive batches of detergent. Because the data are not collected in subgroups, the engineer must use an IMR chart to monitor the mean and variation of detergent process. So, interpret the moving range chart first to examine the process variation. As we can see, none of the points are outside the control limits, and the points display a random pattern. The points vary randomly around the center line and are within the control limits. No trends or patterns are present. Okay, how to do this in Minitab? Choose Stat, Control Charts, and then Variables Charts for Individuals, and select IMR. In the Variables sections, select pH, and then click on IMR Options. Then select Test 1, which is 1 point more than 3 standard deviations from center line, and select Test 2, which is 9 points in a row on the same side of the center line. As you can see, one observation failed Test 1 on the IMR chart because the observation is more than 3 standard deviations above the center line. To ensure that your results are valid, the data should be continuous and also in a time order, because control charts detect changes over time. The order of data is important. You should enter the data in the order it was collected, with the oldest data at the top of the worksheet. The data should be collected at appropriate time intervals. Collect data at equally spaced time intervals, such as every hour, every shift, or every day. Select a time interval that is short enough that you can identify changes to the process soon after the changes occur. The data should be individual observations that are not collected in subgroups. The data should include at least 100 total observations. If you have fewer than recommended number of observations, then you can still use the control chart, but the results are preliminary because the control limits may not be precise. If you use the chart regularly, re-estimate the standard deviation and control limits after you collect the recommended number of observations. The data should be moderately normal. If the data are very skewed, you could try a transformation to see if that corrects the non-normal condition. If your process naturally produces non-normal data and the transformation is effective, you can use the chart of transformed data to assess the stability of your process. Okay, to recap. Step 1. Determine whether the process variation is in control. Before you interpret the individual chart, examine the moving range chart, MR chart, to determine whether the process variation is in control. If the MR chart is not in control, then the control limits on the I charts are not accurate. The moving range chart plots the moving ranges. The center line is the average of all moving ranges. The control limits on the moving range chart, which are set at the distance of the 3 standard deviation above or below the center line, show the amount of variation that is expected in the moving ranges. Red points indicate observations that fail at least one of the tests for special causes. If the chart shows out-of-control points, investigate those points. Out-of-control points can influence the estimate of process parameters and prevent control limits from truly presenting your process. If out-of-control points are due to special causes, then consider deleting those points from the calculations. Step 2. Determine whether the process mean is in control. The individual chart, I chart, plots individual observations. The center line is an estimate of process average. The control limits on the I chart which are set at the distance of the 3 standard deviation above or below the center line, show the amount of variation that is expected in the individual sample values. Red points indicate subgroups that fail at least one of the tests for special causes and are not in control. If the chart shows out of control points, investigate those points. Step 3. Identify which points failed each test. Investigate any observations that failed the test for special causes. By default, Minitab conducts only test 1, which detects points that fall outside of the control limit. However, if you conduct additional tests, then points can fail multiple tests. Alright, in this video, we covered different control charts used in manufacturing processes. If you like this video, please don't forget to subscribe to this channel and leave your comments below. We will continue to make such videos for you. Thank you. We are going to release video series on different topics including application of statistics in manufacturing and quality control, robotics and mechatronics, industrial machine vision, system dynamics, finite element analysis with abacus, GD&T and tolerance analysis, and many other interesting topics. Don't forget to subscribe to this YouTube channel to get notified when a new video on this topic is released.